Hello, space enthusiasts! It's Mr. Andrew here, and today we're going on an interstellar journey to explore the amazing world of space exploration. From the early days of the space race to the latest groundbreaking missions, space exploration has captivated our imagination and pushed the boundaries of human achievement. So, strap in and get ready to blast off as we dive into 10 mind-blowing facts about space exploration that will leave you starstruck. Don't forget to hit that like button and subscribe to our channel for more thrilling adventures into the cosmos. Now, let the countdown begin! The space race, a competition that changed history. The space race was an intense period of rivalry between the United States and the Soviet Union during the Cold War, fueled by their desire to showcase their technological prowess and assert dominance in space. This competition led to some of the most remarkable achievements in the history of space exploration. The space race began in 1957 when the Soviet Union successfully launched Sputnik 1, the world's first artificial satellite. This event caught the United States off guard and sparked a sense of urgency to catch up and surpass the Soviets in space technology. In response to Sputnik, the United States established the National Aeronautics and Space Administration, NASA, in 1958, marking the beginning of America's ambitious journey to conquer the final frontier. The Soviets continued to make history with a series of pioneering firsts in space. On April 12, 1961, Yuri Gagarin became the first human to journey into outer space and orbit the Earth aboard Vostok 1, a milestone that fueled the competition even further. Not to be outdone, the United States set its sights on an ambitious goal, landing a man on the moon. In 1961, President John F. Kennedy announced the nation's commitment to this audacious mission, sparking a decade of innovation and determination. The Apollo program, NASA's effort to land humans on the moon, took center stage in the space race. With a series of groundbreaking missions, including the tragic Apollo 1 accident, the program persevered and ultimately triumphed. On July 20, 1969, the United States claimed victory in the space race when Apollo 11 astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface, while Michael Collins orbited overhead in the command module. The end of the space race marked the beginning of a new era of international cooperation in space exploration. The Apollo-Soyuz test project in 1975 saw American and Soviet astronauts join forces in a historic docking mission, symbolizing the thawing of Cold War tensions. While the space race was a product of geopolitical rivalry, it undeniably accelerated the progress of space exploration and inspired generations to dream of reaching for the stars. The cost of space exploration: how much do we invest in reaching the stars? Space exploration has always been an expensive endeavor. The investments required for cutting-edge technology, research, and development, along with the costs of launching and maintaining missions, can quickly add up to staggering amounts. During the height of the space race, both the United States and the Soviet Union allocated significant portions of their national budgets to fund their respective space programs. At its peak, NASA's budget accounted for approximately 4.4% of the U.S. federal budget in 1966. The Apollo program, which successfully landed humans on the moon, cost an estimated $25.4 billion, about $153 billion in today's dollars. This enormous investment paid off in the form of invaluable scientific knowledge, technological advancements, and a massive boost to national pride. Since the end of the space race, the budget for space exploration has decreased significantly. As of 2021, NASA's budget represents roughly 0.5% of the U.S. federal budget. However, it's important to note that today's technology allows for more cost-effective missions than during the early days of space exploration. The rise of private space companies, such as SpaceX and Blue Origin, has introduced competition and innovation to the space industry, leading to more efficient and affordable solutions for space exploration. For example, SpaceX's Falcon 9 rocket, which features reusable first-stage boosters, has significantly reduced the cost of launching satellites and cargo into space. The cost of space exploration also extends to the international community. The International Space Station, ISS, a collaborative effort among multiple countries, is estimated to have cost over $150 billion since its inception in the late 1990s. The ISS serves as a vital platform for scientific research and international cooperation in space. Future space exploration missions, such as NASA's Artemis program aiming to return humans to the Moon and eventually to Mars, will require significant investments. These ambitious endeavors have the potential to yield invaluable scientific discoveries and technological advancements that can benefit humanity as a whole. In conclusion, the cost of space exploration is substantial, but the knowledge, inspiration, and innovation gained from reaching for the stars have the potential to yield invaluable returns on these investments. The moon landing, one giant leap for mankind. The historic moon landing on July 20, 1969, marked a monumental achievement for humankind and the culmination of years of intense effort by NASA's Apollo program. It was a defining moment in the space race and a testament to human ingenuity and determination. The Apollo 11 mission, commanded by Neil Armstrong and featuring astronauts Buzz Aldrin and Michael Collins, was the first successful manned mission to land on the moon. The three astronauts embarked on their incredible journey aboard the Saturn V rocket, which launched from Kennedy Space Center on July 16, 1969. Armstrong and Aldrin descended to the lunar surface in the lunar module Eagle, while Collins remained in the command module Columbia, orbiting the moon. Upon landing, Armstrong famously declared, "Houston, Tranquility Base here. The Eagle has landed." As Armstrong took his first steps on the lunar surface, he uttered the iconic words, "That's one small step for man, one giant leap for mankind." The moon landing was broadcast live on television, captivating an estimated 600 million people worldwide and marking a historic moment in human achievement. During their brief time on the moon, Armstrong and Aldrin conducted experiments, collected lunar samples, and planted the American flag. The astronauts spent approximately 21 hours on the lunar surface before rejoining Collins in the Columbia for their return journey to Earth. Apollo 11's success inspired subsequent manned lunar missions, with a total of 12 astronauts walking on the moon during the 6 successful Apollo landings between 1969 and 1972. The moon landing not only fulfilled President John F. Kennedy's ambitious goal, but also demonstrated the United States' technological prowess and commitment to space exploration. It showcased the potential for humans to explore other celestial bodies and fueled the imagination of millions. The moon landing also spurred advancements in technology, with innovations like integrated circuits, telecommunications, and material science, which have had far-reaching impacts on various industries and daily life. In summary, the moon landing was a monumental milestone in human history, showcasing our capacity to push the boundaries of exploration and achieve the seemingly impossible. It remains a symbol of human determination and an inspiration for future generations to continue exploring the cosmos. The International Space Station, ISS, humanity's home away from home. The International Space Station, ISS, is a unique collaboration between 5 space agencies: NASA, United States, Roscosmos, Russia, JAXA, Japan, ESA, Europe, and CSA, Canada. Launched in 1998, the ISS is an orbiting laboratory that serves as a platform for scientific research, technology development, and international cooperation in space. Orbiting approximately 250 miles, 400 kilometers, above Earth, the ISS travels at a staggering speed of 17,500 miles per hour, 28,000 kilometers per hour, completing an orbit every 90 minutes. This allows astronauts on board to witness 16 sunrises and sunsets every day. The ISS has been continuously inhabited since November 2000, with astronauts from various countries conducting research and performing maintenance during their stays, which typically last about 6 months. Research conducted on the ISS spans multiple disciplines, including biology, physics, astronomy, and earth science. The unique microgravity environment allows scientists to study phenomena that would be impossible to replicate on Earth. The ISS also plays a crucial role in preparing for future deep space missions, such as trips to the Moon and Mars. Experiments and technology tests conducted on the ISS help scientists and engineers understand the challenges of long-duration spaceflight and develop solutions to overcome them. Mars rovers, unmanned missions to the Red Planet. Mars rovers are robotic explorers sent to study the surface of Mars and search for signs of past and present life. These unmanned missions have greatly expanded our understanding of the Red Planet and paved the way for future human exploration. NASA has successfully landed 4 rovers on Mars: Sojourner, 1997, Spirit and Opportunity, 2004, Curiosity, 2012, and Perseverance, 2021. These rovers have each made significant discoveries and contributions to our knowledge of Mars geology, climate, and potential habitability. Spirit and Opportunity, twin rovers, were designed for a 90-day mission but far exceeded expectations. Spirit operated for over 6 years, while Opportunity explored Mars for nearly 15 years, covering over 28 miles, 45 kilometers, of the Martian surface. The Curiosity rover, part of NASA's Mars Science Laboratory mission, continues to explore Mars' Gale crater, studying the planet's climate and geology and searching for signs of past microbial life. Its discoveries, such as the presence of organic molecules and a more habitable ancient environment, have significantly advanced our understanding of Mars. The Perseverance rover, along with its companion helicopter Ingenuity, arrived on Mars in February 2021. Perseverance's main objective is to search for signs of ancient microbial life and collect samples for a future return mission to Earth. Ingenuity, the first aircraft to fly on another planet, serves as a technology demonstration to test powered flight on Mars. Both the International Space Station and Mars rovers have played vital roles in advancing human knowledge and capabilities in space exploration. Their ongoing contributions will continue to shape our understanding of the universe and pave the way for future endeavors in the cosmos. Voyager 1, the most distant human-made object in space. Voyager 1 is a NASA spacecraft launched on September 5, 1977, on a mission to study the outer solar system and beyond. Its twin, Voyager 2, was launched 16 days earlier. Both spacecraft were initially planned for a 5-year mission to explore Jupiter and Saturn, but their journeys have far exceeded expectations, making groundbreaking discoveries and lasting over 4 decades. Voyager 1 made history in 2012 when it became the first human-made object to enter interstellar space, crossing the boundary of the heliosphere, the region of space dominated by the Sun's influence. Voyager 1 is now more than 14 billion miles, over 22 billion kilometers, away from the Sun. During its journey, Voyager 1 conducted flybys of Jupiter and Saturn, sending back stunning images and valuable data on their atmospheres, moons, and other features. Among its many discoveries, Voyager 1 provided detailed images of Jupiter's Great Red Spot and revealed the existence of volcanic activity on its moon, Io. Voyager 1 carries the famous Golden Record, a time capsule containing images, sounds, and messages representing Earth and humanity, intended for any extraterrestrial civilizations that might encounter the spacecraft. The record includes greetings in 55 languages, music from various cultures, and a diverse selection of natural and human-made sounds. Although its cameras have been turned off since 1990, Voyager 1 continues to transmit valuable data from its other instruments back to Earth, providing unique insights into the interstellar medium and the boundary between our solar system and the rest of the galaxy. SpaceX's reusable rockets, revolutionizing space travel. SpaceX, a private aerospace company founded by Elon Musk in 2002, has revolutionized space travel with its groundbreaking advancements in reusable rocket technology. By developing rockets that can be launched, landed, and flown again, SpaceX has significantly reduced the cost of space travel, making it more accessible and sustainable. The Falcon 9, SpaceX's flagship rocket, made history in 2015 when it became the first orbital rocket to successfully land back on Earth after delivering a payload to space. This marked a major milestone in the quest for rocket reusability. Since then, SpaceX has continued to refine and improve its reusable rocket technology, achieving numerous successful landings on both land-based platforms and autonomous drone ships at sea. This has allowed the company to reuse its first-stage boosters multiple times, driving down launch costs and increasing the frequency of launches. SpaceX's Falcon Heavy, the world's most powerful operational rocket, also features reusable first-stage boosters. Its maiden flight in 2018 demonstrated its capacity to carry heavy payloads to space while still landing and reusing its boosters. The development of reusable rockets has significant implications for the future of space exploration, making it more affordable to launch satellites, resupply the International Space Station, and embark on ambitious missions to the Moon, Mars, and beyond. In summary, Voyager 1's incredible journey into interstellar space and SpaceX's reusable rocket technology represent remarkable achievements in our quest to explore and understand the cosmos. These milestones showcase human ingenuity and our relentless drive to push the boundaries of space exploration. The James Webb Space Telescope, the next generation of space observation. The James Webb Space Telescope, JWST, is a highly advanced, infrared-optimized space observatory developed by NASA in collaboration with the European Space Agency, ESA, and the Canadian Space Agency, CSA. It is designed to succeed and expand upon the discoveries made by the Hubble Space Telescope, which has been in operation since 1990. The JWST is equipped with a 6.5-meter, 21.3-foot, primary mirror, significantly larger than Hubble's 2.4-meter, 7.9-foot, mirror. This increased size allows the telescope to collect more light, providing higher resolution and sensitivity to observe distant celestial objects and phenomena. Unlike Hubble, which primarily observes visible and ultraviolet light, the JWST is optimized for infrared observations. This capability enables it to see through dust and gas, allowing for a better understanding of star and planet formation, as well as observing the most distant galaxies in the universe. The James Webb Space Telescope will be positioned at the second Lagrange point, L2, approximately 1.5 million kilometers, about 930,000 miles, from Earth. This location provides a stable environment and minimal interference from the Earth and Moon, ensuring optimal observing conditions. Among its many scientific goals, the JWST aims to study the formation of the first galaxies, stars, and black holes, examine the atmospheres of exoplanets for signs of habitability, and investigate the mysterious nature of dark matter and dark energy. Future missions, ambitious plans for space exploration. NASA's Artemis program is an ambitious plan to return humans to the Moon by 2024, followed by establishing a sustainable lunar presence by 2028. The program aims to use the Moon as a stepping stone for future missions to Mars and other destinations in the solar system. SpaceX, in collaboration with NASA, plans to send humans to Mars as early as the 2030s. The Starship, a fully reusable spacecraft currently in development by SpaceX, is intended to transport humans and cargo to Mars and other destinations in the solar system, revolutionizing deep space travel. The European Space Agency, ESA, is working on the ExoMars mission, which aims to explore the Martian surface for signs of past and present life. The mission consists of 2 parts: the Trace Gas Orbiter, which is currently in orbit around Mars, and the Rosalind Franklin rover, planned for launch in 2022. The Breakthrough Starshot Initiative is a long-term project that aims to develop the technology necessary to send ultralight, laser-propelled spacecraft to explore nearby star systems, such as Proxima Centauri. This ambitious endeavor seeks to push the boundaries of interstellar exploration and search for potentially habitable exoplanets. NASA's Dragonfly mission, planned for launch in the 2020s, will send a rotorcraft to explore Saturn's largest moon, Titan. Dragonfly will study the moon's atmosphere, surface composition, and search for signs of past or present habitability. These next-generation observatories, like the James Webb Space Telescope, and ambitious future missions showcase humanity's ongoing commitment to explore and understand the universe. As we push the boundaries of our knowledge, we continue to make groundbreaking discoveries that will shape our future in space. In conclusion, our journey through the fascinating world of space exploration has shown us the incredible achievements and discoveries that have been made, from the historic moon landing to the groundbreaking innovations in reusable rocket technology. The International Space Station, Mars rovers, and the Voyager 1 spacecraft have provided us with invaluable knowledge about our universe and have paved the way for ambitious future missions. The next generation of space exploration will undoubtedly continue to push the boundaries of our understanding, with the James Webb Space Telescope offering new insights into the cosmos, and bold missions like Artemis, SpaceX's Starship, and Dragonfly aiming to expand our reach to the Moon, Mars, and beyond. As we look to the future, the spirit of human ingenuity and curiosity will propel us towards even greater achievements, deepening our connection to the universe and inspiring generations to come.